Question 13. A certain couple tells you that they have 2 children, at least one of which is a girl. What is the probability that they have 2 girls?
Question 15. What do you understand by statistical power of sensitivity and how do you calculate it? Answer. Sensitivity is commonly used to validate the accuracy of a classifier, logistic, SVM, random forest, etc.
Question 16. Why is resampling done? Answer. Sampling is an active process of gathering observations with the intent of estimating a population variable. Resampling is a methodology of economically using a data sample to improve the accuracy and quantify the uncertainty of a population parameter. Resampling methods, in fact, make use of a nested resampling method. Once we have a data sample, it can be used to estimate the population parameter. The problem is that we only have a single estimate of the population parameter, with little idea of the variability or uncertainty in the estimate. One way to address this is by estimating the population parameter multiple times from our data sample.
This is called resampling. Statistical resampling methods are procedures that describe how to economically use available data to estimate a population parameter. The result can be both a more accurate estimate of the parameter, such as taking the mean of the estimates, and a quantification of the uncertainty of the estimate, such as adding a confidence interval. Resampling methods are very easy to use, requiring little mathematical knowledge. A downside of the methods is that they can be computationally very expensive, requiring tens, hundreds, or even thousands of resamples in order to develop a robust estimate of the population parameter. The key idea is to resample from the original data, either directly or via a fitted model, to create replicate datasets, from which the variability of the quantiles of interest can be assessed without long-winded and error-prone analytical calculation. Because this approach involves repeating the original data analysis procedure with many replicate sets of data, these are sometimes called computer-intensive methods. Each new subsample from the original data sample is used to estimate the population parameter. The sample of estimated population parameters can then be considered with statistical tools in order to quantify the expected value and variance, providing measures of the uncertainty of the estimate. Statistical sampling methods can be used in the selection of a subsample from the original sample. A key difference is that process must be repeated multiple times. The problem with this is that there will be some relationship between the samples as observations that will be shared across multiple subsamples. This means that the subsamples and the estimated population parameters are not strictly identical and independently distributed. This has implications for statistical tests performed on the sample of estimated population parameters downstream, i.e. paired statistical tests may be required. Two commonly used resampling methods that you may encounter are k-fold cross-validation and the bootstrap. Bootstrap. Samples are drawn from the dataset with a replacement, allowing the same sample to appear more than once in the sample, where those instances not drawn into the data sample may be used for the test set. K-fold cross-validation. A dataset is partitioned into K groups, where each group is given the opportunity of being used as a held-out test set, leaving the remaining groups as the training set. The K-fold cross-validation method specifically lends itself to use in the evaluation of predictive models that are repeatedly trained on one subset of the data and evaluated on a second held-out subset of the data.
Resampling is done in any of these cases. Estimating the accuracy of simple statistics by using subsets of accessible data or drawing randomly with replacement from a set of data points, substituting labels on data points when performing significance tests, validating models by using random subsets, bootstrapping, cross-validation.